Okay, welcome back. This is the second tutorial where I will cover DirectX setup and initialization. So last time we left off with this, a basic Win32 window. So to begin, we're going to create a new class. It's going to be a utility class, so just call it DXUtil. We're going to get rid of the class definition, so no one cares about that. I'm going to include D3D11, and we're going to include the library. We're going to link to it. And we're also going to create a namespace called memory, which is basically going to contain some template functions for doing basic memory management with deletion of pointers and releasing COM objects. So we're going to create a safe delete one. So if t null pointer, if t, we're going to call release on t, and then set t equal null pointer. And then let's also create one for arrays. Okay, so there we go. So now what we can do is we can go into our app and include utility. And oh, by the way, make sure that you're using, again, Windows 8.0 kit, the Windows kit. Okay, so now we're going to create some DirectX attributes. Now the first, they'll be as follows. So first one's going to be the D3D11 device pointer to a device. Next one's going to be ID3D11. Now every one of the DirectX, these COM objects are prefixed with I. So immediate, no, not immediate context, device context, immediate context. The reason we're calling it immediate is because it's not deferred, it's you know, immediate. We're not rendering like off to a buffer or anything. Well, you are, but not in the sense that I'm talking about. So next thing is the swap chain. Then we're going to need a render target view. And finally, we're going to need some basic structures, driver type, feature level, and viewport. Okay, so that should cover all the DirectX attributes we need. So the next thing we're going to do is create another method. So this one's going to be called init_direct3d. And in here we're going to initialize direct3d. But first, up here, underneath this, we're just going to initialize these pointers to null. Whoa. So there we go. So in our direct 3D initialization, I'm going to move this. First thing we're going to do is create this uint called create device flags. And then if debug, what we're going to do is we're going to set that create device flags equal to basically d3d11 create device debug. Whoa, create device debug. So if we're basically what this does is this is going to be a flag that we pass to our device creation code, and because we set it to create device debug, it'll give us out debug information to like the output window. If you have Direct3D debug enable, but I'll cover that in some other tutorial. Right now we're just focused on actually getting DirectX set up without any real error handling. So next thing we're going to do is we're going to have to create a couple arrays that hold the different supported driver types, possible supported driver types and feature levels. So, and I'll explain what these are. So driver types. Driver type or reference. Okay, so basically this one means that you have basically a graphics card or some sort of Intel integrated graphics that allows you to do transforms, lighting transforms. This is if you don't have that and it's sort of emulated. And this is another form of like reference emulate for like development stuff. Generally you don't want to ever use this or this. You want to always have hardware. So yeah, and make sure that they're done in this order so that the very first thing we check is hardware, because if this succeeds we're just going to break out. And then we're going to store the number, so num driver types equals, we're going to use this macro called array size, which will give us out the number of values in here. So for this it would be 3 basically, or 2 because zero base counting. Next thing is going to be the feature levels. So feature levels. Now what this is basically with DirectX 11 they made it so that you could target any of the previous legacy versions of DirectX. You could target features of them. So you can make sure that if you say I'm only going to support DirectX 9.3 features and above, then you could say you could set what feature levels you actually support. So what this will do is we're going to go through and just set the possible feature levels. So feature levels 10.1. Now what these really do, the differences between them is basically like texture size and some other stuff that it's not really too important, but it's kind of important. But generally we're just going to stick with 11 and just assume that people have so num feature levels. Okay, so now that we have these, we're going to create what's called a swap chain description. Now, what the swap chain is basically, you know how your desktop works? Your desktop basically has, there's buffers. So you have the front buffer and the back buffer. and an image will be written to the back buffer, and then while another image is displayed in the front buffer, and then it just keeps swapping and cycling. So that's sort of double buffered rendering, which makes it so you don't see basically artifacts and other choppy animation. So the swap chain description will describe how we want our swap chain, which handles the buffers and handles how they swap out. So here we go. We're going to create call it swap description. We're going to zero memory it. So cool. Then we're going to set some values. So as you can see, it's got a bunch of different things. So buffer count is the first thing we're going to set, and you're going to set that to 1 because 0 would be single buffered, 1 is double buffered. So next thing is the buffer description. Now the buffer description has a few things. What we're going to want to do is set the width and height. So that's going to be, of course, the client width. And the client height. Next thing is going to be the format. So what we're going to use is, because this is a color buffer, we're going to use the basically 32-bit unorm. So this is 32 bits, so 8 bits for red, 8 bits for green, 8 bits for blue, 8 bits for alpha, and then unormal. Unsigned normal. Don't worry about that, just trust me on it. And then for the next thing is the refresh rate. So numerator is going to be 60, and the denominator is going to be, of course, 1, so we want basically 60 frames per second refreshing, or at least attempt it. Next thing is the buffer usage, so we're just going to set that to render target output. So we want it to render to the target output window, which we'll set next. The output window will be the handle to our application window. Next thing is the swap effect. This one we're just going to set to discard, which is the fastest and most efficient. The next thing we're going to do is set window to equal to true, because we're just in windowed mode right now. Next thing is going to be setting the sample description, which is basically for multi-sampling. So what multi-sampling does is it makes kind of like, like anti-aliasing for pixels. Well, multi-sampling is kind of like anti-aliasing for geometry in a way, a little bit, kind of like in the buffer. I don't know. We're gonna not have any because multi-sampling causes things to lag quite a bit. If you ever played any games on your computer, and if you don't have a beast computer, usually if you have multi-sampling on, even 4 times multi-sampling will kind of wreck your frame rate. So count is going to be equal to 1, and quality equals 0. And finally, the flag is going to be oh, I forget this one. Flag allow mode switch. So what this will do is it allows for Alt Enter full screen. So what this does is when you hit Alt Enter, your window will pop into full screen. The thing is though, it won't resize the buffer, so we're gonna have to handle that ourselves, which will be another tutorial. But yeah, and also I might mention that if you followed my DirectX tutorial before, the other one, the DirectX 9, there was something that we had to do, which was we had to reset the device when it was lost. If we hit like Alt Tab or something like that, the device would get lost. But DirectX 11, there's no more device state getting lost. It's always active, so you don't have to worry about that. It handles it for you. So that's all we need for this, I'm pretty sure. Yeah. So there we go with that. Next thing we need to do is we're gonna go create an H result, which is just basically an error code handle, and then we're gonna loop through. So int I equals 0, I is less than num driver types plus I. We're gonna loop through all our driver types, and we're gonna set the result equal to d3 d11 create device and swap chain. So what we're going to try and do is in one method call, we're going to create our device and our swap chain. Whoa. So first thing it takes is the adapter. We're just going to pass 0 or null in because we're going to use the default adapter. Next thing is driver. The driver type is going to be driver types I. So we're going to choose the first driver type we have. Again, for the module, we don't have any software module we're plugging in, so just set that to null. Flags, we're going to pass in our create device flags. The feature levels is going to be our array of feature levels. The uint feature levels is basically the number of feature levels. The SDK version is always going to be the D3, D11 SDK version. The swap chain is our swap chain description. So the pointer to a swap or reference to the swap chain is our swap chain. Same thing with the device. And this is our feature level we want to store it in, and that actually needs to be best reference. And finally, our immediate context. So basically that's what's needed to create both the device and the swap chain. So what we're going to do is if that's succeeded, whoa, that's weird. Whoa, what's happening? If that's succeeded, we're going to set our driver type equal to driver types at that location in the array, and then we're going to break. But if it failed, we're going to output debug string and then we're just going to return false. So we're going to break out. Okay, so now that we have our device and swap chain, which will allow us to basically create our to set render states and a bunch of other stuff. This handles rendering basically. Swap chain handles actually presenting and managing the buffers. And this handles setting states on the device. So like for instance, like shaders and things like that. You can even check right now the device. If you look, see it does interesting stuff. You can create, pixel shader, create all different stuff with the device. But I'll go more into those when we actually start using them. So next thing we want to do is after we create the device and swap, we're going to want to create the render target view. So now to do this, what we're going to have to do is we're going to have a texture basically what this does is the render target view is basically like a big image that we render stuff to. So in order to do that, we have to create first the texture that we want to bind to the view. So we're going to create a texture 2D. This is going to be back buffer texture. Next thing we're going to do is we're going to go and call, I believe is it this, get buffer, and we're going to pass in null or 0, UUID of D3D11 texture 2D, and then we're going to reinterpret cast to avoid pointer that back buffer texture. So what we're doing is we're going to the swap chain, we're trying to get the buffer, so we're storing that into this back buffer texture. So then what we want to do is, I think it's create render target view, and what we want to do is we want to pass in our back buffer texture, null pointer for the render target view description, and then we're just going to pass in our render target view. So there we go. So that should have created our render target view. Now we have to bind. So I think that's where the immediate context, what we do is we bind that. So we're going to set render targets, and basically we're going to set num views is, I guess, 1, null pointer, oh no, we're going to render target view and then pass in null pointer. So what this does is we're binding one view to the render target view. We're binding that to the render target, and we don't have any depth stencil view because we're not covering that right now. Depth stencil views are for doing effects like shadow mapping and things like that. So that's one example. So there we go, and now finally I believe we have the viewport creation. So right here we're gonna have to do we're gonna set our viewport width equal to static cast to a float our client width. Same thing with the client height. The top left X is just going to be 0. Top left Y is going to be 0. The min depth is going to be 0.0f, and the max depth is going to be 1.0f. And now we're going to bind viewport. So set viewports, so rs set viewports 1, and then we're just going to pass in viewport, and then return true. So what this should do is this should set up our application to render using DirectX 11. So to test this out, first, before we test anything out, we're just going to handle some memory cleanup, and we're going to actually call our method. So if not init direct3d, return false. And then next, in here, in our destructor, we're going to clean up. So first, we're going to check to see if the immediate context exists. Then we're going to call clear state on it to clear its complete state. And then we're just in the opposite order to where we created these. We're going to release them. So the first thing we're going to release is using our memory. safe release is the render target view. Next, we're going to release the I'll just do it this way: swap chain, immediate context, device. So there we go. So now we released all these from memory. Okay, so while that should had worked, what we're going to try and do is test it. So to do this, what we're going to do is we're going to go into the util. We're going to add one more thing in here called DirectX colors. Now this is included in the Windows kit. These don't exist in the SDK. That's why you need to, for this tutorial, you need to be using Visual Studio 2012 with the Windows 8 SDK. So we're going to go back here, and in render, we're just first going to clear render target view with the immediate context. We're going to pass in our render target view, and we're going to go DirectX colors cornflower blue. So what this is this is the new namespace included in the Windows 8 SDK, and it has a colors namespace with all these predefined colors that just work by passing in. Originally, you would have to have created a float like this, color equals, and then a bunch of like float values. But now they have a bunch of predefined ones that just work by passing in. Next thing, we're just going to have the swap chain present. So what this does is it flushes basically the buffer to our screen, to our window. And hopefully this will work if we run. Okay, so it didn't work. Let's see why. Well, first off, I can go like this. Okay, so I'm pretty sure this should have been a reference, not just a pass of the pointer. Let's try it now. Okay, there you go. So now you have it clearing to cornflower blue. So it works. So now you have DirectX 11 set up. Now you can change this to anything, purple. There you go. So there you go. That's DirectX. You can even go if you hit Alt Enter, it'll go full screen. The problem is, while it does look like the whole thing is being colored, it's stretching the pixels, so it's not actually resizing the buffer. So I'll cover that in another tutorial, but for now, that's about it. That's DirectX 11 setup. Thanks for watching.